as far as at IRI, we started developing the crop models, dynamic simulation models. That means mechanistic models taking into all processes of plant growth, as well as taking all processes in soil in terms of fertility, in terms of, let us say, the water movement, all those things. So first time actually we started working, actually that was first time happening in Asia. So, and our association was with Wageningen Group through ERI, as well as Michigan. Dr. Ricci also used to interact with us very frequently. And the first model which we could develop came in 94, WT Grows, Wheat Growth Simulator, which became very popular. We used it for climate change, and even it became part of several models being tested on a global platform, and then actually for climate change and other applications. So that way then we thought of that, let's try to develop a model which is capable of handling more or less all the crops within the country. So that was InfoCrop, where actually we could integrate 16 crops. Then simultaneously we developed for rubber and coconut for Sri Lankan. I was actually advisor to Sri Lankan government there. I developed that model. So the story of dynamic simulation models started from IRI, Dr. Agarwal and myself. And we trained around more than 400 scientists within the country through a World Bank Center of Excellence program. Actually, we were having NATP World Bank program on crop modeling, where we trained several scientists not only within India, outside in Bangladesh, in Indonesia, Nepal. Now also I am associated with UN programs for training these people. So then actually we could demonstrate the modeling applications for resource management, for optimum sowing windows, for varietal characterization, idiotypic designs, climate change studies, water management studies, nutrient management studies. So several applications we could demonstrate. So that actually broke my discipline boundaries, though I am actually a agriculture physics, soil physics background. But then actually some person confused that I am a physiologist, some people say that I am a biochemist, some people say that I am a breeder. So that way actually the entire actually discipline boundaries got broken. And we always believed in working in team, and then actually working on combining all the kind of disciplines together in order to work out the response. So as far as crop model is concerned, it's basically integration of weather, soil, crop and management. These are the inputs. Crop model is the mathematical equations, and then the outputs can be yield, leaf-free index, nitrogen uptake, and plant partitioning, those components, all those things. Actually, as far as the simulation models are concerned, if we talk only of the G by E interaction, that means genetic by climatic interaction, that is level 1, that is potential yield. So potential yield of wheat can be 7 to 8 tons, rice can be about 10 tons now, the potential varieties. But then we talk of the attainable yield, which is normally when we bring into the soil depth into consideration. So the wheat yield can be up to 6 to 7 tons, and then subsequently the actual district yield or block yields are of the level of 4 tons in Punjab or 3 tons in UP, Western UP, like that actually. Then there is a yield gap. We try to quantify the yield gap. We try to identify the factors responsible for the yield gap, and then try to give the management strategies in order to narrow down the yield gap. So then actually system 2, level 2 is when we bring into the water stress. So that means G by E into water. Then system 3 is G by E into water into nitrogen. Then actually system 4 is G by E into water into nitrogen into other minerals. Then subsequently insect pest component. Most of the models within the globe are not taking into account the insect pest components. The InfoCrop model actually we could develop, which we developed only in 1 year. Although the WT grows, wheat growth model took around 10 years for us to develop, because that's the first time experience, 84 to 94. So about 20 PhD theses actually came out from our students actually, and then we could integrate and develop that model, as well as maybe more than 200 theses or 200 PhD theses on wheat helped us in developing the WT grows. Subsequently, InfoCrop took only 1 year for 16 crops. Now actually our capability is that we can develop a model within within a week time or 10 days if the subject matter specialty is with us. We want to, let us say, include the aerosol effect. Like say I was panel member, UNEP panel member for aerosol. So there actually I could develop that routine within 1 hour and then actually showed the applications. Tea and coconut model for Sri Lanka I developed only in 1 week. So that way now that confidence is there and the entire group activity we can help the process in order to develop those things. Now the simulation model developed at IRA, WT grows, ORISA actually we were part of IRI program. So IRI, the nitrogen interaction model was developed by us. So that ORISA 1 and then info crop, info soil process. Then actually we have been using almost all the entire global models because I am part of AGMIP. AGMIP actually the last presentation where actually the kind of the deviations were there within that. Basically the question asked by Carr actually was that why these calibrations are not happening. There are several processes of modeling. One is actually calibration and then actually validation for those field environments. The model which is validating well for our conditions has to be taken for application platform. It's basically not the intention of comparing the models. It's basically using that model which is working well for our conditions. So InfoCrom model actually is developed at IRA. So basically the inputs are weather components and then actually the insect pest component is a forcing variable. At a given point of time we force the kind of the insect pest problem in that crop. And subsequently then actually the model takes care about the population dynamics and the kind of the losses and the control options, yield loss and other things. The kind of the inputs for soil in terms of texture, salinity, sodicity, fertility, moisture retention, transmission. We have developed the water pedo transfer functions also on the basis of simple texture also we can derive these parameters. Then the varietal characters in terms of physiological, phenological and genetic coefficients which actually to our chairman I was telling that. To some of the existing varieties already all those coefficients are there in All India breeding coordinated trials. Actually we try to use those things on the multi-locational trials and then try to develop those parameters. Maybe in that case actually the experimentation efforts, the labor gets reduced. And then actually agronomic inputs in terms of seed, in terms of irrigation and all those things. This is the actually flow chart for InfoCrop. It's about, it's a very detailed model talking of the water balance component, talking of the nitrogen balance component, talks of the greenhouse gas emission also, talks of the carbon sequestration also, talks of the residue management also. It's a very classical model actually. Because I have used almost all the model for our Indian condition and Asian environment, InfoCrop fits well and suits well for all the environments. Because it's basically designed on the basis of Indian, because for developing this model actually through World Bank program, actually we tried to invite several workshops where actually we had a interaction with about 100 scientists, different cross specialists in order to develop this model. And then actually we gave liberty to those people in order to publish their own contributions. So that way they gain confidence and the national platform, those kind of preparedness was there. So our actually this model actually is a unique model talking of the yield losses because of the insect pest, where we talk of the pest, weeds are also there, insects are there, and then the diseases are there, and the kind of the damage mechanisms and the kind of the forcing at a given point of time actually we require. Now actually this is very important. Actually we try to define the potential yield, attainable yield and actual yield. This type of analysis we have done for all the crops for all the country locations. And we have tried to define that what are the yield gaps in different locations and whether because through the breeding, through evolving some varieties or through agronomic management practices, we have to narrow down the yield gap. So all those kind of options actually we have debated. Within this part of study, last actually when I was at IRA, about 10 PhD students of mine worked on several crops, working out the yield gaps and working out the resource management and then subsequently used the climate change. Even Agarwal students also worked on that. So it was a kind of a joint team where actually we could initiate several people. Now those people are mostly outside the country because they had developed the confidence of crop modeling so they could go outside. So now application of simulation models in estimating potential yield and yield gap, optimizing fertilizer management. Actually in 2007 I took voluntary retirement from IRA because I wanted to develop a multi-nutrient direction model, which was not possible at IRA, so I joined Tata Chemicals as director of their R&D center at Aligarh, where I developed that multi-nutrient detection model, which I coupled with the infocrop in order to design the customized fertilizer and the different kind of fertilizer routines. So I had experience of corporate as well as 30 years experience of IRI. So that gave me a lot of experience that how these models have limitation in operational applications. So that actually kind of experience I got in Tata Chemicals, where I had a network of about 600 locations. There all agronomists were there, and I used to conduct several experiments there. Then yield forecasting. This first time actually we could do with Space Application Center ISRO, and we demonstrated an application of crop models for yield forecasting, linking the satellite platforms. Then impact assessment of climate change. We have been associated with IPCC since long, and we have our reports are part of IPCC. And NETCOM also. NETCOM, National Communication also, our reports go as far as the country applications are concerned. Environmental impacts in terms of nitrate leaching, in terms of, let us say, the water table declines, in terms of, let us say, the land degradation and all that. Plant idiotypic design, which our chairman sir actually is very much interested. Through modeling, we could demonstrate the kind of the plant idiotypic designs, and we could help you a lot in terms of that process for NICRA actually. Genotypic by environment interactions, and then weather-based agro-advisory services. You see, our IMD, weather-based agro-advisory services, though conventional platform IMD is there, but then actually we want to make it online, agro-advisory, depending on, we want to use the crop models. I'm in the advisory panel of that, and I'm helping their network of about 400 network stations are there, and about 300 scientists are there with their all staff. I'm trying to help them in developing those kind of modules and linking the operational methodology for that. Now this is one of the application where actually I say that a climatic potential yield of wheat in India. You see for Punjab, it's not working. Now you see, if I talk of Punjab, my yields are between 7 to 8 tons as far as GY interaction, only genetic by climatic interactions are concerned. Haryana, and then subsequently you see that this is on the basis of 50 years weather, normal weather for these locations. So all these MET subdivisions are there, and 50 years weather I run the model and then get the result, try to find out the median yield of that. So accordingly you see that potential yield wise, already the yield 50% chances in those probability are worked out, and if I try to see the district wise yield or MET subdivision wise yield, they also have the same pattern but at a lower platform. So I try to define the kind of the yield gaps, I try to have linkages with the climatic variability. Yesterday also I told that the climatic variability, year to year climatic variability, if I am able to capture with the crop growth model, I am able to capture it, then subsequently that can help me in climate change. If my scenario of temperature rise of 1 degree or 2 degrees there, automatically through climatic variability response, I develop the technical coefficients, and those response help me in working out the response impact. Because the kind of the phytotrone or growth chamber studies have limitations of location specificity, very narrow kind of regions. So those have very high elevated values, yield reduction, which may not be really applicable. So those kind of limitations are there with OTC and phase chambers for carbon dioxide and temperature studies. So those limitations are already, because we have last 30 years experience on crop modeling, and we have been associated with several international platforms, and they also treat us as an advanced center for crop modeling. So that's why I keep on going to almost all the countries as well as advanced countries also for these platforms. So that way actually this particular, then actually this is one slide which shows you that this is no temperature rise. With 1 degree temperature rise, you see, with different dates of sowing, this is 1 degree temperature rise, 2 degree temperature rise, 3 degree temperature rise. That means, what is adaptation strategies? Adaptation strategies, if climate change has taken place, what should be the agronomic management option in order to have the maximum production? So you see that with the 6 days delay in sowing, I am entering into that platform if 1 degree temperature rise is there. If 1 degree centigrade temperature rise is there, if I delay the sowing of wheat by 6 days, then actually I enter into the maximum yield window. But then actually there is a reduction in the yield. So that type of thing actually we have done for almost all the locations, important growing locations of the country. I'm showing for Pantnagar, for 60 locations, 70 locations for wheat. For almost all the crops we have worked out. So because we have been working for crop modeling since 30 years back, so we have done all these analysis for the country. So that way actually we have all soil database for the entire platform, about 20,000, 30,000 soil database values, weather data records for last 50 years for almost all the weather locations, pedo transfer functions, and then the inputs, data sowing distributions. The question actually which your Jayaraman was telling, that rowing survey, crop cutting trials, Ministry of Agriculture, you could get a lot of things. We need not do the village kind of trials because almost all those locations are covered. So that way actually we are able to have those kind of things. Now actually this is one very important slide where I am talking of the temperature rise as well as radiation reduction. Because of aerosol, the radiation can be reduced also. And then actually you see that in terms of the biomass, this is a conservative value. Total biomass is conservative in all these kind of temperature rise as well as the aerosol phenomena. But we have much variation in terms of the yield. So the sensitive parameter economic yield is there that actually we are able to capture. This is on the basis of the our infocrop validation results. We should not take particular model for application window unless we are sure that that particular model is working well for our condition. We have to have calibration with our own experiments, and then subsequently we have to validate it for independent weather data sets. Like say last time the last presentation Modipuram data was showing not the validation, it was calibrated, but both the models were showing a different result, and then subsequently taken to application, where we were not very clear that how actually which is well and which is working well and all that. So that way those kind of model limitation one has to understand before actually you see, now see potential yield of wheat. For almost you see about 400 locations we run the model, and we made the potential yield, wheat yield map of the entire country. So that way, wheat yield map, rice yield map, oil seeds, all the crops actually we have made the potential yield map, attainable yield maps, the district level yield which we take on the basis of the statistics, the Ministry of Agriculture statistics, and then we try to work out the windows. Now this is one very important slide, that if let us say 450 degrees centigrade temperature rise, and then 2 degrees centigrade temperature rise and 450 CO2 level, the shifting of the productivity center northwards. So how actually the climate change is going to happen? So that kind of scenario building is there. Now actually I'll very quickly pass through that it's not only climate change, the other kind of drivers are also there. Now you see the nutrient deficiencies within the soil in Indian environment happening very fastly. Now we developed a customized fertilizer at Tata Chemicals, where a single granule providing all NPK, zinc, boron, sulfur as per the need of that particular region for target yield of a crop. So that was using all these materials together through steam granulation process, and we could transform into a single granule. And that single granule is having all composition of NPK, zinc, boron, sulfur, except that 20% of nitrogen is there, and rest 80% we do the split application. Other all nutrients are in complete dose as per the target yield and that region. So for that we did the graded soil sampling for Western UP, Bengal, about 1 lakh soil sample we collected, and we did the fertility delineation, and with this approach of modeling, we could develop the crop model, this particular nutrient optimized model. And then this was the model which was used for optimization. And then actually we conducted trials in the farmers field for developing the customized fertilizer for wheat. We used for Western UP about 50 locations, and at each location about 30 farmers, and then we could develop this kind of fertilizer, which gave us a 26.5% yield, increase in yield in paddy, 15.2% increase in wheat, 12% increase in maize, and then potato 17.7%. So it's a kind of a revolution. The first time happened in the country, and Government of India changed the rules also in order to bring this particular kind of thing. So soil health service is one thing. I'll take 2 minutes, sir. So 2 minutes. So soil health, basically you see the message which I want to give you here is that in soil testing, millions of data set of soil testing platform is there in the country, but no operational window for soil health service. in terms of tillage management, in terms of fertilizer management, in terms of irrigation management and all those things. So actually we are trying to work on soil health service in a way to develop that decision support system for developing that kind of health service. All these things are important from viewpoint of climate change also, because then actually we are talking of the soil databases. Then in terms of the resource conservation technologies, where we talk of zero tillage, minimum tillage and bed planting and all those things, there actually the kind of the controversies are there. Somewhere, some location it's giving a positive effect, somewhere it is giving a negative effect. So ultimately we have to use the crop models, develop the model and take to independent locations for testing in order to work out the short and long-term consequences of these kind of tillage management on the soil health as well as the productivity response. So that is the message which I want to give you. So in terms of the remote sensing application, which Sai also must be presenting, first time actually at IRA along with Space Application Center, we linked the satellite data with the crop models and the relational layers of inputs for yield forecasting. And this type of platform linkages of layers of biotic and abiotic stresses along with the crop models and climate change scenarios is the answer for working out the impacts. Otherwise, most of the IPCC report for India and other countries are point application studies, don't take into account the kind of the regional variability in spatio-temporal as far as the biophysical and socio-economic aspects of these stresses are concerned. So ultimately, this is the last slide, where actually we say that my mission is crop growth monitoring system for a country like India, which is an intensive agriculture with the diverse kind of inputs, diverse kind of crops and cropping systems, where we want to have the online agro-advisory in terms of pre-sown, operational, post-harvest, outlining optimal production zones, planning crop cycles with weather and market, inputs management. Our stakeholders can be farmers, agri-clinics, researchers, NGOs, planners and agro-industries. My 30 years of R&D experience with multidisciplinary background, working with more than 500 scientists at IRA, and then subsequently taking to corporate sector, opened my eye that how actually the models have to use as a regional platform. I could understand my mistake of giving the results of climate change, and most of us giving the results to IPCC and NETCOM, they are all location specific, but taking a kind of a regional extrapolation with a lot of error propagation. So we have to be careful in that. And to the entire group, I want to say that maybe we have to be careful in order to understand and in order to choose those kind of models which are very, very specific for our country and for our South Asian region, in a way to take that platform to climate change window, taking also into account the kind of the soil health and the other kind of biotic, abiotic stresses. Thank you very much.
Thank you very much. Thank you.